We are finding slope using a graph. We are talking about slope. So, before we talk about slope, and before we even start with notes, I have a couple of things to remind you of and kind of introduce you to. Anytime you walk up a hill, you're walking up a sloped ground. Anytime you ride your bike down, drive down a hill, you ski down a hill, you sled down a hill, you hike up or down. These are all slopes. However the mountain tilts, however the street tilts, whether it's really steep or really flat, that has a slope. And we can measure how big the slope is. So, if I'm standing at the bottom of a hill, about to walk up, there's the top of the hill, right? There's my destination. The way that we find slope is by not just counting how many steps you take up the hill. There's a method. It's rise and run. So what I have to do is I have to first decide how high my distance is. So I count. Let's say it's 3 feet high. So that's going to be how much I rised. I went up. I personally did not go up, did I? But the destination, my end point is 3 feet higher than where I am. Then we count how far over it is to get there. So maybe that's like 5 feet. And I'm running. So here's my rise. How high is my destination? How far across is my destination? And that's how we calculate slope. I want to remind you that whenever we've gone up and down, that's our y-axis, isn't it? So my rise is also the same as my y. Whenever I go across on graphs or on lines, that's my x-axis. So that distance from here to there across, horizontal, x-axis, is also my run. Y over x. Where have you seen y over x before? When in the past chapter, or even we talked a little bit about it yesterday.
Y over x plus b?
I'm looking specifically for y over x.
I'm like so close.
How much the table skips?
How much the table skips.
What's the table
That's
called?
right.
Table of values. So we did one of these yesterday, right? 8, 6, 4, 2, let's say. How my y changes over how my x changes. -2 over 1, y over x. This is the same as slope. The word rate of change is the same as slope. We talked about rate of change in functions. We talked about rate of change yesterday. I brought it up. Then this, slope, means the same thing. But now we're talking about graphing a line on a graph. But first we need to be able to figure out how much does the line tilt? How steep is this line? How flat is the line? So that's what slope is all about. And that is what we are doing today. So your goal is blank. All right, here's your goal. What we are doing today. Use rise and run, y over x, or rise over run, to find the slope on a graph. Use rise and run, which is y over x, or rise over run, to find the slope on a graph. Okay, to the journal. If slope means steepness, like we just said, how steep is that hill that you are bike riding up? How flat? So if steepness is the same as slope, then what would a large slope? If I said that hill has a large slope, what would that mean? It's steep. But Think in numbers. Like what would a large slope, like what number would a large slope be? A 10. So that means that it would be, you know how it's rise over run? It'd be like 10 over 1. That would mean, here's your picture that you're drawing, that you are going to go rising 10 feet up and 1 over. That hill is like crazy steep. Excellent definition choice you guys picked. 10 over 1. So a large number, a large slope is a larger number. Okay? Even 4. 4 over 1. Up 4 over 1. That's still a hike to get up. Okay. So there's your sentence and there's your picture. What about a small slope? A small number. Give me some examples of small numbers. 2. I mean, 2 and 3 you still have, it's a hill.
1, 2, 2.
A negative means downhill. Means I'm walking down a hill. Negative means downhill. So I don't want that. I don't want steep, I want flat. Zero's no incline at all.
1.
3, 2.
1. Can you think of something that's
1.5.
1.5 lower? A half.
2.5.
Check this out.
5.
Or 1/5. Or 1/8. Anything. But here's what it would look like. I'd go up 1 and over 5. Check out that one. See how that's kind of a flatter hill? Flatter slope? And 1/5. Would you be happy if I said, hey, I'm going to give you all 1/5 of $1? That's a super small number. Not exciting at all. 20 cents. That's what it would be. I'd give you all 2 dimes. Kind of not exciting. Small number, flat. Okay? These small numbers, fractions. Because 1 over 1 looks like this. Up 1 over 1. Exactly the same size. But that's a decent hill, right? We want flat. Okay? Okay. So, one thing that I want to talk to you guys about is a little refresher, because we're going to be working with fractions a lot. Rise over run, fraction over fraction. I need to make sure that you are solid on things like this. Three over 6 equals, or 6 over 3 equals. You need to know the difference. This is literally a 4th grade skill right here. Reducing fractions. With Common Core, it could be a 2nd grade skill now, unfortunately, right? So, which is which?
Divided by 3.
No, I'm reducing this fraction.
Divided by 3.
Okay, so then I'm going to make this one smaller. 1 over 2. What's 6 over 3? You need to know that. When a smaller number's on top, you're going to have a fraction. If the bigger number is above, it'll be a whole number. Or improper, right. And how about like 12 over 4 versus 4/12? Which one is 3 and which one is 1/3? You need to know.
3 is the top, 1/3 is the bottom.
3 is the top. Bigger number on the bottom. How many times does 4 go into 12?
3.
Yep. And then 1/3. Okay. So let's start on, that's just like something I wanted to introduce to you, because if you're bad at reducing fractions, I wanted to kind of nip that before we got started. Okay, number 1. This is practice from yesterday. Plot the 2 points. Go ahead and do that. -1, 2. -1, comma 2. Plot that dot. And then plot 3, comma 0. So everybody's -1, comma 2 look right. Okay, now connect the dots. La 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 la. I'm going to do my best. All right. So, you connected them? Connect them? Now, we need to rise and run. Whoa, craziness.
That's crazy.
Here's a tip. Put this in the margin. Number 1. Start at lowest point and rise straight up. Copying this down in the margin. Start at lowest point and rise straight up. So I'm only going up as high as my next point goes. I would not go past my point. Step 2 is run. And you guys understand that you're going square by square. Square by square. You have to count. 1 square, 2 square, 3 square. Run to the point. So here's how this works. Pause. Nope, simplified always. What is -2 over 4 reduced to? 1 over.
-2.
Okay. More to put on your paper. Little sideline. Are you good with number 1? Okay. Down at the bottom, let's do this in purple. I need you to know that a 1 over a -2 is the exact same thing as a -1 over 2, and it's the exact same thing as -1/2. It doesn't matter where the negative goes. They all mean the same thing. So yeah, the 2 was negative on the denominator, but it still means that the whole fraction is negative. So that purple, that's important to remember too. There's lots of important stuff today. My slope is -1/2. And it's negative y. How did I know it was negative?
Onto the left.
Mm,
Onto the left.
tell me how the line looks.
Downhill.
Downhill. Downhill lines are always negative. Downhill lines are always negative. Going down, negative. Uphill, positive. Up, up, up. Go to 2A. The points are already there. Start at the lowest point, right here. Block by block. Don't try and overextend and go fast. 1, 2, rise, 3. I can't go any higher because then I'd be above where I want to go. You can only go up 3. Rise over run. Same thing as y over x, right? My y, I went up 3. My rise, I went up 3. Start at the lowest point. Now, how many do I run? 1, 2, 3, 4. And I went to the right, and you all said that right was positive. My slope, which we will also call m, is 3/4. I can't simplify that. Questions so far? Do you need to make the hoops? Are you okay? Okay. Start at the lowest point. Which one is lowest? Wait. Neither of them are lowest. Oh, you're telling me the answer already?
Yeah.
You guys are so fast. Okay, rise, you can't go up at all. I can't go high or low. But I can run. I'll just start at the left side. 1, 2, 3, 4, 5. 0 over 5. This is a horizontal line. It's flat. This has no incline, no slope. It's a flat line, no slope. Right? Doesn't that make sense? The ground that I'm walking on is flat, 0. So, another thing to remember. If 0 is on top and then there's a number at the bottom, that's a 0 slope. My slope, my m is 0. 0 divided by 5, 0. However, if there were a number on top and 0 were at the bottom, 0 were undefined. You guys, that line would be like this. Try walking up a straight up and down. Can't do it. Undefined. Can't walk on it. Undefined slope. Can't walk on this. Where are you at so far? Thumbs, showing me your understanding level, basically. You got it? Up, side. Down means I'll come hang out with you. All right. Number 3, remember this? Yeah. We've done this. Okay. Slope, don't forget, is y over x. Please tell me, how is look at the number line if you need help. How is -3 becoming -6? What's happening over there on the number line that I am moving? I'm subtracting by 3s. What's adding 2. -3/2. Do number 4 with the people at your table. Check your answers, make sure that they have what you have what they have, or help them if they're not getting it. Now, what did you and your group get for number 4? Did you check with them? Check with them. Make sure that you're going to give me the right answer. 2 over 1? Class, do you agree? I do too. So far, so good, right? Okay. The back side is your classwork. And I threw a little wrench in it because only on number 1 did I give you the dots. Okay? So let me see if I can do this. Yeah. Okay. Notice how my dots are on perfect intersections. I did not put a dot in the middle. Corners, guys. Corner, 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 corner. So now, starting at the lowest point, this one, how many do I rise? 1. Oh, but I'm going to the left.
1.
-1. Rise. 1 over -1. Because I went to the left. Remember when I pointed my hand? You guys said that way was negative, didn't you? So make sure that you write that when you're doing movement. So there's number 1. 1 over -1. Wow, how sweet. Number 2, I get to expand. I love this. Okay, there's no dots. Darn it. I'm going to zoom in, and I want you to tell me when my little... Okay. Tell me when I get to a perfect intersection. A corner.
Oh.
There?
Yeah.
Everybody make a dot right there. Okay, I'm not done. I gotta make more dots. Okay, tell me. No, that's in the middle. That's not a corner.
Oh, stop.
Okay, make a dot there.
Wait, you have to make a bunch of dots?
Well, I'm gonna have you do 3, just so that we know that the pattern is sequential. It has the same pattern. Okay.
Stop. Now stop.
Okay. Well, I gave you 3 dots. All you had to choose from was really 2. So I'll say, pick the lowest point. Here. And rise. Just to the next purple. 1. Run now. 1, 2. You got to go square by square. I had a person last period who was trying to do like this. They didn't. So the point is that it's a totally legitimate mistake, you guys. Don't laugh. I've totally done things that afterwards I'm like, oh my God, I'm such a tard. 2. Run 2. 1/2. Now, let's say someone was like, but I want to go to the third one. I want to do the third one. Okay, that's fine. Watch this. Red. 1, 2. Over. 1, 2, 3, 4. You can rise and run any points you feel like it. But look, guys, 2 over 4 reduces down to?
1/2.
You're going to get the same answer no matter which points you rise and run to. Gosh, for all I wanted, I could go all the way up here if I wanted. This red way up there. Whatever. It's going to reduce down to 1/2. Hold on, let me first. Oh. I've only screenshotted to 3 and 4. Okay. 3. Tell me when to make my dots.
Stop.
Okay, someone has to say something. I'm not going to be doing this by myself. It's going to continue in that pattern. Knock yourself out. Make 5 dots. That's fine. And knock yourself out. Rise and run. But start at the lowest point. It's a must right here. Because that way you're always rising first. When you start at the lowest point, you're always rising first. 1, 2. You should do the little whoosh, whoosh, whoosh. Run, -1. Right? -1. But what's 2 over -1 the same as? No. It's like, Alondra, do you want me to give you $2? Or do you want me to give you a $0.50? Are they the same? 2 over 1 is the same as what? 2 over negative 1 is the same as what?
-2.
Negative 2, just negative 2. Remember? Negative 2 over 1 is the same as 2 over negative 1 is the same as just negative 2. Doesn't matter where you put your negative, you're going to get a negative answer. Yeah, all the time. My rule doesn't work if it's negative over negative, obviously. Okay. Here we go again. Do 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 do. Stop. You're right. Yeah, I'm hoping. You think so? Again. Dun 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 dun.
Stop.
Whoa. Insane how far apart they are. Okay. Start at the lowest point. This one. Rise straight up. 2. 2 squares, 2 blocks, right? Run to the right. 2, 3, 4, 5. Two over 5. 2 fists. You always rise first. Up first. Always go up. That's why we start at the lowest point. Okay? Go ahead and continue on.